Hello and welcome back to our series Getting Started. My name is Gordon Dotterman. I'm from FTC Team 8372 Trial and Terror. And today we will be going over how to use the three most important sensors: the touch sensor, the color sensor, and the gyro sensor.
So these are the three sensors we will be going over in this video. We have the Modern Robotics touch sensor, the Modern Robotics gyro sensor, and the Modern Robotics color sensor. So this is our touch sensor. It's a very basic sensor, but it's incredibly important for any robots. It has a single button on the front and runs a 3-pin cable out the back, which can be plugged into either the analog or the digital ports. However, I suggest the analog. So just like that, when you plug it into power source, it should light up whenever you press it, just to make sure that it's working correctly.
So this is the Modern Robotics touch sensor. It has a button on the front. It's very straightforward. It can be put on sides of your robot to tell it when it's run into a wall. It can be used in certain places to make sure that the robot doesn't overextend itself. So it's a very simple but very useful sensor. So there are only two methods for the touch sensor. There is pressed, which returns true if the touch sensor is being pressed. And the get value, which represents how much force is being applied to the touch sensor. Now this will scale from near zero, so as you push more, it will get as a higher number.
This is a Modern Robotics integrated 3-axis gyro. Now basically it has no buttons or no outer uses. However, inside there's a gyro that will tell you its rotation in the z-axis as a 360-degree heading. Also, if you're interested, it provides you raw rotation values in the x and y axes as well. However, that will be really hard to use, and so I just suggest sticking with the z-axis. This is an I2C pin, and so you can just plug it into any of the I2C ports, and it will work perfectly. As a debugging tip, it will light blue when you are using it.
This is the Modern Robotics integrated gyro. This is an incredibly important sensor for anyone who wants a reliable autonomous. It gives the rate of rotation for the x, y, and z axes, as well as heading information from the z axis. So what this means is that the x, y, and z axes will basically give you acceleration on those axes, and the z axis will give you a heading from 0 to 360 degrees. So the z axis is obviously the most useful one just in its raw form. However, you can use the x and y rate of rotations if you so desire. Now there is a lot to take in about the integrated gyro. So the first and most important method is the calibrate method. Now this will take a few seconds, and I suggest putting it in your initialization area, and will basically calibrate the gyro so that it knows which way is forward. So you have to do this right before any autonomous programs that you're running to make sure that it's an accurate gyro. So get heading will return the integrated z-axis as a Cartesian heading as an integer. So 0 to 360, pretty straightforward. Get rotation returns the rotation of this sensor. Is calibrating tells you whether or not the gyro is still calibrating, so this can help speed things up a little bit and make your robot move on to the next task as soon as it's done calibrating. Raw X, raw Y, and raw Z respectively will give you the X, Y, and Z values as their acceleration. Finally, reset Z-axis integrator will reset the z-axis to 0. So no matter where you're headed, if you're headed at 45 degrees and you call this, it will set it back to 0, and then you can rotate from there. Finally, Team 9804 Bomb Squad has made an incredible guide on how to steer with this sensor. They made it when it first came out, and I have found it extremely useful. I will give you the link in the description, and it is also on the Modern Robotics website for this sensor if you so wish to do that.
Finally, this is our Modern Robotics color sensor. It has an LED light on one side and a sensor on the other side. The sensor will bounce light off of any surfaces you wish to sense the color of, which will bounce back whatever color it is, and the sensor will pick that up and give you a raw reading. This uses a 4-pin I2C port, so you can just plug it into any of your I2C ports on your device interface module, and it should work perfectly.
So this is the modern robotics color sensor. As I said, it has an LED and a sensor on the front to detect the light. It can be put on the bottom of a robot to sense a line or a color change. It can also be put on the side of a robot to sense a change in the colors of beacons. So this can be an extremely useful tool in sensing change on the field. Now for the color sensor, there are a lot of commands, but they're all pretty straightforward. The alpha, so alpha is the amount of light detected by the sensor as an integer. This will get much higher as the surfaces become more reflective. ARGB returns the hue from 0 to 255 as an integer. This can be very useful for just sensing basically a change in overall color. Blue will get the straight blue values as an integer, and green and red are the same as blue, just with different colors. So this can be extremely useful. So low numbers will mean that there is practically none of that color in whatever you are sensing, whereas high numbers will mean there is a lot. So these will probably be your most used functions, however the other ones are also useful. Finally, there is an enable LED method that will allow you to enable the LED if it worked. However, I have not had any success recently at making this work. It might be our hardware, however, just keep that in mind that it may not turn on the LED. As a quick extra sensor, this is the motor encoder. Now most motor encoders are built into the motors themselves. Some are external, however for Neverests and I believe motors they are built in. Now this will give you a reading of how far your motors have moved in an integer form. So each integer or each count or whatever you want to call it, it does not directly correspond to how many rotations you have made. One does not correspond to one rotation or a quarter rotation. Rather, they correspond to how many ticks the actual encoder has. So if you want to know how many ticks take an entire rotation, you should look up your encoder online and find the ticks per rotation number. So to get these points, you can say motorname.getCurrentPosition, which will return the current encoder value. Now, an important note is that the value cannot be reset back to 0, just like the gyro. It stays counting for the entire program until it stops, so just keep that in mind.
So as a quick side note, you cannot plug the touch sensor into the Rev Robotics Expansion Hub because of a difference in wires. However, you are able to convert these two I2C sensors into the Rev Robotics Expansion Hub with a few simple wires.